Okay, let's suppose we have this graph. This is distance in miles and this is time in minutes. It could be a car, a person running, or anything else, any object. So when time is in 3 minutes, the person or the car reached 4 miles. From 3 to 6 minutes, it's 10 in 4 miles, and from 6 to 8 minutes, go up from 4 to 6 miles. So let's suppose that the exercise tell us to make a sketch of the corresponding velocity function, the corresponding velocity. Now I should know that the distance, the derivative of the distance, this is d of t. This is any graph d of t. So d prime of t, which is the derivative of the distance, it's equal the velocity. The velocity in terms of t. So the derivative of the distance is a velocity. Once we have this graph, what we do is, again, we do a small sketch. We plug in the same values in t, which is the time 3, 6, 8, 3, 6, and 8. Now, if we look at this first part here, that is 3 to the x and 4 to the y, remember that this 4 is delta y. So delta y, it's equal 4, and delta x, it's equal 3. If you think about it, what is delta y divided by delta x? That is the slope. And what is the slope? The slope is the derivative of the function in one particular point. So 4 divided by 3 is the slope. And the derivative of the distance is the velocity. But for linear equations as this one, the derivative and the slope is the same, because in all those points the derivative is the same, which is the slope. So 4 over 3, it's the derivative of the distance, that is a velocity. So at this point, 4 over 3 here, 4 over 3, that means that from 0 through 3, this is the velocity that the object has in that point. Then we have the second interval, that is from 3 to 6 here. And we can say that the distance keeps the same, keeps constant. So this function is y equal 4, but the derivative of y equal 4, the distance is it's equal 4. The derivative of that, it's 0, because the derivative of a constant is 0. So that will be the velocity. So from 3 to 6, here it's what's happened. The object is like you stand in the same place, the time is running, but the distance keeps the same because you stop for any reason. And then in the third, here in the third interval from 6 to 8, now the object is running again because there is a change in the distance from 4 to 6. So this one is a linear equation. So we can find the slope. Remember, the derivative is the same as the slope in a linear equation. Okay, the distance would be the delta y. The slope is the delta y divided by delta x. Delta y is 6 over 6 minus 4, 2, and 8 minus 6 is 2. So for this third part, it's 2 over 2, the slope. That is the derivative of the distance, that is the velocity. Okay, velocity, it's equal to the derivative of the distance, it's equal to the slope, it's equal to 2 over 2, it's equal to 1. So here 4 over 3, it's 4 over 3 is 1 and 1/3, a little bit more than 1. So 1 should be around here. So from 6 to 8, this is what's happening in the graph. Now, the first graph is distance, time. The second graph is velocity, time. Velocity, time. So the sketch of this graph according to this graph distance time, the sketch of the velocity for this information is this one. The object has a speed from 0 to 3 minutes, has a speed of 4/3, that in this graph represent like this. Then the object stop from 3 to 6, stop. There is no change in the distance because the object is stopped. And that is you represented here, which is 0. For the velocity is 0 because the object is stopped. There is no running. And then from 6 to 8, there is another velocity here less than this one because this one is 4/3, this one 2/2, that is 1. And the object keep running. In 1, the first one is 4/3. So this is the sketch velocity respect to time for this graph. I hope this video helped you. You can see it again. If you are familiarized with derivative, that will be very easy for you. If you're not, maybe that would sound kind of tricky or complicated. But I recommend you to understand derivative very well. You should go through slope. What is the slope of the line first? Go through some basic rules of derivative. You need to pass through a limit process, and then you will understand derivative.